Welcome to the debate. Today, we are dissecting a paradox that plagues technical education, specifically in the realm of data science. It's a phenomenon that Federica Gazzaloni identified during her time with Our Lady's Rome. And frankly, if you've ever taught a workshop or tried to learn a coding language yourself, you have seen this face. It is the face of the capable student, the one who knows the syntax, who has memorized the verbs, who can type out the code, yet freezes completely when asked to answer a simple analytical question. We're really looking at the architecture of data fluency.
Right, it's that gap between knowing code and actually doing data. And it's where most curriculums just go to die. We're drawing heavily from Gazzaloni's pedagogical writings, her work on sustainable data learning, her book on health metrics, and her development of the Type R package. But really, what we're talking about is the difference between owning a dictionary and having a conversation.
And the central inquiry is this: how do we bridge that gap? I'm here to argue for structured design and the art of omission. I believe that true learning requires a carefully curated architecture, a system that protects the learner from cognitive overload and prioritizes, conceptual reasoning over just the technical implementation.
And I am here to argue for process visibility and friction. I believe that these polished learning paths create fragile learners. Real fluency is born in the messy moments, the debugging, the environment setup, the errors. If we hide the friction of practice, we aren't really teaching. We're just performing. Then let's get into it.
I want to start with that specific moment Gazzaloni described in Beyond the Syntax. She's running a workshop. She has a participant who isn't a beginner. This person can write tidy pipelines, they can import data, they know filter, mutate, and ggplot. They have the tools. But when Gazzaloni asks a simple question, calculate prevalence by group and explain what changed, the student just freezes. They say, I know the functions, but I don't know what to do. To me, this is the smoking gun. This is not a confidence problem. This is a learning design problem. It proves that syntax is merely a surface layer. We have spent so much time teaching people the vocabulary of the tools that we've neglected the grammar of the problem.
I recall the anecdote well, and I agree it's a failure, but I think the diagnosis is different.
How so?
Well, you say the student froze because they lacked a blueprint or a system. I argue they froze because their learning environment was likely, it was too perfect. In a workshop, everything is pre-configured. The data is clean, the packages load without any conflict, the instructor types a command, and it just works. But that is an illusion. As Gazzaloni points out in The Friction of Practice, designing a session creates this illusion of control. When that student is asked to do analysis, they're suddenly facing the reality of the work, which is just full of ambiguity.
But ambiguity is exactly what a novice cannot handle.
But ambiguity is the job. If we overstructure the learning path, if we polish away all the rough edges, we aren't protecting the learner, we are deceiving them. We create an expectation that data science flows in a nice straight line. But real work is the back and forth of iteration. It's trying something, inspecting the output, realizing your assumption was wrong, and adjusting. That friction isn't a distraction from learning, it is the learning.
I strongly disagree that friction itself is the teacher. Friction without a mental model is just frustration. It's heat without light. Let's look at the core of the debate: the role of syntax versus conceptual reasoning. You seem to imply that if we just expose students to the messiness of coding, they'll eventually figure it out. But Gazzaloni is very clear in Architectural Foundations of Sustainable Data Learning. She states that, quote, without structure, even excellent tools become overwhelming. Take her example of health metrics. You have concepts like life expectancy, YLL, years of life lost, and YLD, years lived with disability. These are not just random variables you throw into a regression. They are a system. They are conceptually linked. If a student doesn't have the formal definitions established, if they don't understand that life expectancy is a summation of years lived, then all the friction in the world won't help them debug their code because they won't know what the result should even look like.
Okay, I am not arguing against definitions. I value conceptual clarity as much as you do, but I am challenging how that clarity is achieved. You want to front-load the structure, build the formal definitions and composite constructions before the application. You want them to read the architectural blueprints before they've ever held a hammer.
Because if they swing the hammer without the blueprint, they build a shed that collapses.
Or they learn how gravity works. Consider the reality of the online gap discussed in Pedagogy in Motion. When we move from live to online or from a textbook to practice, the central challenge is visibility. In a live setting, small breakdowns are productive. A code block fails. A plot looks wrong. The instructor says, "Oh, wait, let me check that." That right there, that is the process visualization.
But that can be structured.
Can it? Because when you look at how most structured courses are delivered, especially recorded ones, that visibility is edited out. The recorded session problem is very real. The instructor removes the typos, the pauses, the moments of uncertainty, all to make the video efficient. But by doing so, they remove the elasticity of the thinking process. Gazzaloni argues that learners need to see how decisions are made in real time. They need to see the instructor struggle, even just for a moment, to understand that uncertainty is not a failure state. If your structure eliminates that visibility in the name of cognitive load management, you are teaching them that if they don't get it right the first time, they are failing.
I think you were conflating structure with artificial perfection. They are not the same thing. Structure is about sequencing. It is about the art of omission. Let's look at Gazzaloni's book, Health Metrics and the Spread of Infectious Diseases. She explicitly discusses the difficulty of deciding what not to include. She calls it pedagogically harmful to include every edge case, every method, or every tool just because it exists.
And that is where I get nervous. Pedagogically harmful to include the truth of the tool's complexity?
It is harmful to dump the entire complexity on a novice all at once. Omission is not simplification, it is prioritization. She chose examples over exhaustive formulas. She chose to introduce concepts before methods. This protects the learner from burnout. If you throw a student into the deep end of environmental friction, installation issues, terminal errors, compatibility problems, before they even understand what a rate is, you aren't teaching them resilience. You are teaching them that this field is impossible. Structure allows understanding to compound. You build the foundation, intuitive explanations, then you build the walls, formal definitions, then you put on the roof, applied analysis. You don't ask them to frame the house while fighting a hurricane of syntax errors.
I love the house metaphor, but in your version, the student moves into a pristine model home, and the first time a pipe bursts, they have no idea where the shutoff valve is because you omitted the plumbing diagram to save them from cognitive load. Gazzaloni explicitly states in The Friction of Practice that obstacles like compatibility issues, terminal fears, and environment setup are not conceptual obstacles. They are infrastructural ones. But, and this is key, she says, this is not failure. This is the structure of practical learning. When we omit these infrastructural obstacles from our teaching, we create a misalignment. The student feels lost, not because the math is too hard, but because they are fighting the tool and they think they shouldn't be. If we acknowledge that friction, if we made the setup time and troubleshooting time part of the official curriculum rather than an annoyance to be minimized, we would validate their experience.
But there is a difference between validating their experience and letting that experience derail the actual learning objective. Gazzaloni notes that learners rarely feel lost because content is too advanced. They feel lost when prerequisites are assumed but not surfaced. My argument for structure is exactly about surfacing those prerequisites in a controlled way. If the goal is to teach the concept of years of life lost, and we spend 45 minutes of the hour debugging an R package installation, we have failed. We have let the friction consume the reasoning. That is why I advocate for the art of omission. We must filter the complexity so the learner can focus on what matters now. We can introduce the terminal later. We can introduce the messy dependencies later. But we have to establish the mental model first.
That sounds nice in theory. We can introduce it later. But do we? Or do we just leave them to drown in the gap after the course ends? Let's talk about the tools, specifically the Type R package Gazzaloni developed. This is a fascinating case study because I think it supports my view, though I suspect you'll claim it for yours.
I certainly will. Type R is a triumph of structure. It allows an instructor to simulate live typing, to compile code in a controlled way. It restores pacing. In online learning, attention is fragmented. If an instructor just flashes a completed code block on the screen, the student disengages. Type R forces the flow of information to match the speed of cognition. It slows the session down. It is a tool designed to impose structure on the digital environment.
See, I view Type R not as a tool for control, but as a tool for process visibility. The problem with online teaching, as Gazzaloni notes, is that passive viewing limits active reasoning. When code just appears, it's magic. Type R forces the instructor to make thinking explicit again. It simulates the rhythm of live coding. Why is that rhythm important? Not because it's tidy, but because it reveals the construction. It allows the learner to see the code being built line by line. It's about the process, not just the result. But I want to go back to your point about the art of omission being an act of care. I actually agree that authorship and teaching are acts of care, but I argue that the greatest act of care is honesty.
Honesty about what?
Honesty about the context. Gazzaloni mentions that code can run perfectly and still answer the wrong question. That is the danger of the syntax-first or highly structured approach. You can get a student to reproduce a perfect pipeline, they get the green check mark. But do they know what a row means? You argue that structure teaches this. I argue that interrogating the output teaches this, and you only interrogate output when things look weird or when you are forced to debug.
I disagree. You don't only interrogate when things look weird. You interrogate when you have a rigorous definition of what right looks like. Let's look at the health metrics example again. Gazzaloni outlines a path. Foundation, intuition, build, formal definitions, apply simple models, extend, sensitivity analysis. This is a loop. It's not just getting it right. It's about audit trails and interpreting outputs responsibly. You cannot interpret an output responsibly if you are just iterating until the error message goes away. That is brute force learning, and it creates bad analysts. You need a mental model like the system of life expectancy to even know what to check. Without that structure, the iteration is aimless. The student who froze in the Our Ladies workshop didn't freeze because they hadn't seen enough error messages. They froze because they couldn't translate the question, what changed, into operations. That is a failure of reasoning, not a failure of friction.
But reasoning is not an abstract activity. You speak of it as if we can sit in an armchair, read a definition, and suddenly possess reasoning. Reasoning is an emergent property of practice. You learn to translate what changed into operations by trying to group by and summarize, looking at the result, realizing you grouped by the wrong variable, and doing it again. Gazzaloni writes, in practice, this back and forth is the work. She explicitly says, many learners think this means they are failing. Why do they think that? Because we have structured their education to look like a straight highway. If we taught them that misalignment and uncertainty are the default states of data work, they wouldn't freeze. They would experiment.
But you are assuming they have the capacity to experiment. Gazzaloni talks about cognitive load. For a beginner, the syntax, the environment, the logic, and the statistical theory are all competing for working memory. If you maximize friction, you overload that memory. They don't learn resilience. They learn nothing because their brain is just managing noise. The art of omission says, let's remove the environmental noise for a moment so they can focus on the logic. Let's use Type R to control the pacing so they don't get left behind. Let's use a book with a curated path so they can see the whole picture before they get lost in the pixels.
And I ask, when do we add the noise back in? Because if your structure constantly protects them, you are creating the tutorial hell phenomenon. They can do anything inside the tutorial and nothing outside of it. Gazzaloni asks a pivotal question in The Friction of Practice. What can be deferred without harming understanding? You say we can defer the technical friction. I say if you defer it too long, you have harmed understanding because you have presented a false image of the discipline.
I am not saying we hide it forever. I am saying we use structure to mirror professional practice while giving learners room to explore. Note the phrase, room to explore. You cannot explore if you are terrified of breaking the environment. A reproducible workflow, a templated analysis,
These are professional tools that provide safety. They allow the learner to tinker with the variables without blowing up the laboratory.
I will concede that safety has value, but I worry that templated analysis becomes a crutch. Gazzaloni mentions that authorship is one of the most demanding forms of learning. Why? Because it forces you to decide what is central. When she wrote her book, she had to leave things out. That deepened her understanding. But the student doesn't get to go through that process of selection. The student receives the pre-selected path. Unless we invite them into the messy process of selection, of deciding what data to use, how to clean it, how to deal with the ugly reality of it, they are just consumers of our structure, not architects of their own understanding.
But that is exactly why we need systems. Authorship is a demanding form of learning. Precisely, we cannot expect every beginner to rederive the entire field of health metrics from scratch through friction. We must stand on the shoulders of giants. We must use the curriculum design to give them the benefits of Gazzaloni's synthesis. She writes, structure is not about adding rules. It is about making learning easier for the brain. Why would we oppose making learning easier for the brain?
Because easier often means shallower. If the brain doesn't struggle to connect the dots, if the connection is spoon-fed via a perfect transition in a recorded video, the neural pathway is weak. The struggle, the misalignment, signals to the brain that this is important. I am struck by her comment on process visibility. Learners need to see how explanations develop alongside the analysis. That implies the explanation isn't pre-baked, it evolves. If I am an instructor and I use Type R to perfectly paste a script I wrote 3 weeks ago, am I showing them how explanations develop, or am I showing them a play?
You are showing them a model of clear thinking. You seem to think that watching someone stumble is the only way to learn how to walk. I argue that watching someone walk correctly, with a clear explanation of why they are stepping there, is far more efficient. Gazzaloni says, teaching once works when novelty is enough. Teaching repeatedly exposes the limits of ad hoc material. The friction approach is often ad hoc. It relies on whatever random errors pop up that day. Structure is sustainable. It scales. It allows a student in Rome and a student in New York to follow the same logic.
But does it allow them to solve a problem that isn't in the book? That is the ultimate test.
Yes, because they have internalized the system. They know that life expectancy relates to YLL. They know that a row represents an observation. They have the mental model.
Or they know how to reproduce Chapter 4. I think we are circling the definition of fragility. You think fragility comes from a lack of concepts. I think fragility comes from a lack of exposure to reality.
And I think exposing them to reality without concepts is simply cruelty.
Perhaps. But maybe cruelty is the wrong word. Maybe it's immersion.
Let's pivot slightly to the online gap again. We touched on Type R, but what about the emotional component? Gazzaloni mentions that online, silence is ambiguous.
Yes. In a live room, you feel the energy. You see the confused faces. Online, you just have a void.
Exactly. And in that void, structure provides security. If a student is following a clear numbered path, the silence is less terrifying. They know where they are on the map.
Or in that void, without the visual cues of others struggling, they assume they are the only ones who don't get it. This is why I harp on visibility. If the instructor is perfect, the silence reinforces the student's imposter syndrome. The instructor typed it and it worked. I typed it and it failed. I am broken. If the instructor shows the friction, whoops, I forgot to load dplyr. Let me fix that. The silence becomes shared. Oh, they make mistakes too. That breaks the isolation of the online gap far better than a perfect syllabus.
I agree that showing humanity is essential, but mistakes should be productive mistakes, not infrastructural chaos. We must distinguish between the friction of reasoning, which is good, and the friction of tools, which is often pointless for a beginner. Gazzaloni's point about misalignment is key here. When intrinsic load, the math, and extrinsic load, the setup, collide, learning stops. My winning argument is simply this: we must reduce the extraneous load so the intrinsic load can be mastered. That is what structure does.
And my counter is that in data science,
The tool is the intrinsic load. You cannot separate the math from the machine. To pretend otherwise is to teach a theory of swimming without ever getting wet.
We're nearing the end of our time. I want to try to synthesize this. We both agree that the goal is reasoning. We both agree that syntax is just the surface.
Agreed. We both want the student to stop thinking about mutate and start thinking about prevalence.
My position remains. To get there, we need to build architectural foundations. We need books, systems, and curricula that curate the experience, omitting the distractions to focus on the core concepts. We need to move from intuition to application through a designed path. Authorship is an act of care, and that care manifests as structure.
And my position remains that that structure must not become a cage. We must ensure we aren't creating learners who can only function inside a tutorial. We must value process visibility, showing the mistakes, the debugging, and the friction of practice. We must teach them that feeling lost is not a defect, but part of the work.
Perhaps the answer lies in the pacing. Structure early, friction later?
Or perhaps structure around the friction, give them the safety net, but let them fall.
A fair compromise. Ultimately, Gazzaloni asks us to reflect. Where do you introduce structure and where do you allow for friction?
It's a question every teacher and every learner needs to answer for themselves.
Indeed. Learning is not linear, but maybe the path to it can be. Thank you for listening.
Join us next time on The Debate.